All right, this is lesson 2.6 in algebra. Oops. Okay, ratios and proportions. You've been doing this for years, but we got to make sure you have it. What is a ratio? What is a ratio? What is a ratio? What do you think? Right. It would be like a comparison of two numbers. You know what I'm saying? Like you said, for every 5 paper clips, you have $1, or for every, 1 hour, you have 10 miles, etc. It's a comparison of numbers. Here's the deal. Let's talk about how equal ratios. This is really what we kind of do a lot. Is we use equal ratios. Equal ratios being 2 to 4 and 3 to 6. Okay, equal ratios. Equal ratios form a very special pair of ratios called a what? A proportion, right? Equal ratios form what is called a proportion. Okay? Here's the deal. Here's how you can look at two ratios and see if they form a proportion. We've done this before. We'll go back to the 2/4 and I have 3/6. I mean, you all know that they form a proportion, but here's how you do it. Do you remember how you do it? Just what's the quick way of doing it? Cross multiply. You take the denominator of one and multiply it by the numerator of the other, and the denominator of the other and multiply it by the numerator of the other. 2 times 6 is 12, and 4 times 3 is 12. If they multiply to the same number, then it is a proportion. You don't need to say it's an equal proportion. What does the word proportion mean? That they're equal, right? That would be redundant. So two ratios that when you cross multiply, if their products are equal, they form a proportion. Another way of doing it is this. If I have 1/5 and I have 5 25ths, what's another way of quickly determining whether or not they form a proportion? Mr. Campbell? What was that? Right, well, here's the deal, right? You could reduce them. This is the absolute truth. Proportions always reduce to the same thing. That's one thing, right? So you could reduce this and go, okay, this already is reduced, and I divide this by 5, divide this by 5. This becomes 1/5. They are the same, right? Just like when I had 2/4 and 3/6. What do they both reduce to? 1/2, 1/2, right? Proportions can be reduced to the same number. Okay? But if I do, let's do this. What if I have 2/5 and 10 25ths? Yes, they can all be reduced, but what about this? Notice this, that if I take the numerator over here and the denominator over here, and I do the exact same thing to them, that they will equal this. What I mean by that is this. If I multiply, how does the 2 become a 10? Times 5, and this becomes times 5. Oh, if I multiply them both, the top and the bottom, by 5, and they do equal this, then that tells you that they are a proportion. The other way of doing that would be to, like you said, just reduce it, and by reducing this, it becomes this. Does that make sense? So it will, in fact, work. Those are the simple ways of determining whether or not they form a proportion. Tell me this, is 6/10 and 2/5. Do they form a proportion? Do they form a proportion? How can you tell really quick? Well, here's the deal. If I ask you if they form a proportion, I don't care how you figure it out, right? I don't care how you figure it out. You tell me the answer. Ideally, you will use one of the methods that I just mentioned. First of all, I can look at this, and for lots of reasons, I can look at this and go that number is bigger than 1/2. This number is less than 1/2. I can do that just by, this bang, bang. Oh, not a proportion. Right? Does that make sense? That's one way of doing it. You could even reduce, you could even go, okay, this is 3 210ths, and this is, 10 30ths. And you go, okay, does that form a proportion? This is almost what number? 0. I mean, it's right next to 0. And this one is way more towards a half than this one. Does that make sense? So you could just, not close, right? Not even close. Not a proportion. But, okay, what about this? So when we go back to the 6/10ths and 2/5, what are some more, other than just estimating, what are some things you could do here? Okay, this would be divide by 3, and to go to this is divide by 2. Not the same, right? Not the same. That's one way. What's another way? Cross multiply. 2 times 10 is 20. 6 times 5 is 30. Not the same, right? Not the same. Not a proportion. Okay, we can do ugly ones, though. We can do like 4/10ths and 6/15ths. That one's kind of a weird one, because it doesn't, you go, well, 4 doesn't multiply. It does multiply to something to get 6, but it's not a whole number. And so that way doesn't really work. When they're not whole numbers, it doesn't really work. Does that make sense? You can do it, and I can tell you that this is times 1.5, and this is times 1.5. But, like most of the time, you're not going to know that. And so whatever. So then what's the easiest way of quickly telling whether or not these form a proportion? Cross multiply. 6 times 10 is 60. 4 times 15 is 60. A proportion. Right? I could also, what else could I do here? It takes a little longer. I could reduce, divide this by 2, divide this by 2, this is 2/5. Divide this by 3, divide this by 3, this is also 2/5. They reduce to the same number. That means it's a proportion. I don't care how you do it. I would like to think that you would want to choose the most efficient way, the simplest way. And that's why I give you all these tools so that you can quickly decide which is the best way for each one to figure out. Now, what if it's a big ugly one? What if it's, 1.72 over 4.8 and, 4.65 over, 10.2. And you go, well, hold on. This is going to be a little less than half. That's a little less than half. They could be, right? Trying to reduce this, it's a decimal, not very easy. So then what would likely be the best way of doing this? Cross multiply using your calculator, right? You could easily cross multiply and use a calculator. And if they're not absolutely identical, not a proportion. Does that make sense? Not a proportion. So anyway, if this formed a proportion, I would be a miracle because I just made those numbers up, right? I doubt they do. Anybody checking? It doesn't? Okay. All right, so let's try something else. How then, so remember, what is the surefire way to always do it is to cross multiply. That's how you can tell whether or not two ratios form a proportion. That's the surefire way. Sometimes you don't need to because you could figure it out in other ways. But what happens if they give you a proportion? Okay, they give you a proportion. Now, how do you know this is a proportion? How do you know that's a proportion? Because what? There's the equal sign. They're telling you that this ratio and this ratio are, in fact, equal. So what makes something a proportion? Two equal ratios, right? Two equal ratios makes a proportion. So then, is this a proportion? Absolutely. Now, we have a problem in that we don't know what this numerator is, but we do know that it forms a proportion. Okay, so what do you think we do here at this point? There's actually a couple of ways to do this. There's several. One is you could go do the long way and go, is the variable happy? No, why not? He's not alone. What's going on with him? Why isn't he? He's being divided by 12. What could I do here? I could multiply this by 12 and multiply this whole thing by 12. That would absolutely work. It will work doing that, no question. What is 20 divided by 40, by the way? 1/2. So I could go, okay, what's 1/2 times 12? What's half of 12? 6. That would work, right? That is not always the best way. I'll tell you right now that the most surefire way, especially when you're able to use your calculator, is to just cross multiply. So if I have here's my question again, x over 12 equals 20 over 40. Isn't that what I had? Okay, is to do, well, first of all, you know what would also be super easy? Is if you notice, remember, before you do anything, wouldn't you like to simplify things? Can I simplify this any? Can I make that any simpler? Can I combine things or do anything? Can I simplify x over 12? No. Can I simplify 20 over 40? Can I make that easier to work with? Oh, I can. So then that would be a very easy time to go x over 12 equals 1/2. Now I'm dealing with a much different number, right? Easier. But even if I didn't do that, let's just do it the long way. We're using calculators here, right? Cross multiply. I still want you to put a line on the equal sign. Cross multiply. What is x times 40? 40x equals, what is 12 times 20? 240. Okay, this is just like a normal equation here. Divide by 40, divide by 40. X equals, what's 240 divided by 40? 6, just like we decided before. Does that make sense? That's how you solve a proportion here. When they say solve a proportion, it means that there's something that needs to be solved. There's a variable somewhere. I mean, I could give you, what if I gave you this? Okay, I'll change that 3 to something else a little more palatable. -2. This thing's ugly. Why is it ugly? First of all, line on the equal sign. Is the variable happy? No, why not? He's the denominator. Variables hate that. They hate being the denominator, right? So then, I have options here. In this situation, you can do it my old way, like where you go, okay, how would I get that guy out of being a denominator? Multiply both sides by y, right? You could do that, absolutely. That makes -2 equals 10y. That would absolutely work. What's another way of doing this now that we're talking about proportions? Is this a proportion? Absolutely. Now, what a proportion is a fraction, 2 fractions, right? So then how is this a proportion? What can I do? 10 over 1, right? It's 10 over 1. So then what do I need to do? Cross multiply. Boom, boom. Y times 10 is 10y equals -2 times 1, -2. It's exactly what we just showed. Right? It's just a different way of doing it. Does that make sense? And now we go divide by 10, divide by 10. Y equals -1/5. You always reduce when you can. Any questions about that? Okay. You ready for one that's... Well, I'll give you a couple of these samples and we'll see how you do. Okay? We'll give you a couple of simple ones. All right. We'll do this one. 3/8 equals 15 over x. And then we'll also give you one with a decimal. W over 2 equals 4.5 over 6.8. Do those two for me. So look here, lined on the equal sign. Can I simplify that at all, the 3/8? Can I make that any simpler than 3/8? No. Can I make 15 over x any simpler than, okay. What do I do then? Now I'm going to put 3x over here. How come? What? Could I put 3x over here? Yeah, I can do whatever I want, right? But I'm going to put it over here. Why? Because I want him over there. Right? Eventually, he prefers the left side of the house anyway. Equals, what's 8 times 15? Divide by 3, divide by 3. X equals 40. How many of you got x equals 40? Nice. The next one, line on the equal sign. Again, we're dealing with calculators, so there's no, cross multiply. 6.8w equals, what is 2 times 4.5? 9. Divide by 6.8, divide by 6.8. W equals, on your calculator, when you type in 9 divided by 6.8, what do you get? 1.3. Exactly? Right. What are they? What does it say? Okay. So the instructions, I would have given you instructions saying round the nearest tenth, round the nearest hundredth. It's going to tell you today to round the nearest hundredth, so that would be 1.32, right? That would be your answer right there. How many of you got that 1.3 something, like you got there? Okay. Question? Why would you do that? What's the question? The question has decimals. So your answer should have decimals, right? Okay, here's a good one. Let's try this, baby. I like it. Now, I want you to be able to do this because you know the rules. You just learned how to do the rules, so you do them right now. And I hope you all can do this. 7 over 4 equals f minus 4 over 8. The rules don't change just because it looks ugly. Here's the deal. What do I do here? What do I do? Oh my goodness gracious. What do I do? Line down the equal sign, and then I cross multiply, right? 7 times 8 is 56. That's the easy one. Now I've got 4 times f minus 4. Do I write it like this? 4f minus 4. Is that what I do? No. What is the secret about this? There's a parentheses up here, remember? And so it would be 4 times f minus 4, which I now use the distributive property. So it goes 56 equals 4f minus 16. Does that make sense? So keep watching. Plus 16, 4f equals, what is that? 72 divided by 4, f equals 18. How many of you got f equals 18? Did you see the steps there that you have to go through, right? You're just cross multiplying. You just got to remember that it's in parentheses and you go 4 times that whole thing. That's the distributive property. Now, one last type of question. Question, Saul?
I did multiply the 8 sides and then reduced it. That's it.
Whatever. Makes sense. There's lots of ways to do it. Okay. What about this? Now, here's the deal. You ever heard of a scale drawing, like a map? So let's just say we have our little map here, and here's the X marks the spot, and here's the trees, and there's the rocks. Okay, and on this map, it says the scale is 1 inch. No, we'll make it more difficult. 2 inches equals 100 yards. No. Equals 75 yards. Okay, 2 inches is 75 yards on the map. Makes sense? And we look over here, and I'd say, well, then how far is 5 inches? How far is 5 inches? This is where you have to be able to form your proportion, right? You have to figure this out and form the proportion. The first part of the proportion is right here. 2 inches is 75 yards, right? That's the first ratio. You know that 2 inches on this map is 75 yards. And I'm now asking you, 5 inches is how many yards? Does that make sense? You got to line them up, inches and inches on the top, yards and yards on the bottom. And I'm going to put an equal sign. This is true. 2 inches is 75 yards, and I want to know 5 inches is how many yards, right? Line down the equal sign. What do I do? Cross multiply. 2 question mark equals, what is 75 times 5? $375. Divide by 2. The question mark is, what is 375 divided by 2? 187.5 yards. Right? Make sense? Makes sense? Okay. I'm going to give you guys a small little couple of practice ones to do. They're going to be nice. Hardest one on the page. Here we go. 2n minus 4 over 5 equals 3n plus 3 over 10. There's that one. You do that. And then I want you to do, on my map, right, X marks the spot. All right, so here we go on the first one. It's ugly, but you can do this, right? I mean, you see, what are you looking at here? What do you see here? You see, what do I see? What do I see? What am I looking at here? When I see this right here, what am I looking at? I'm looking at a proportion, right? As soon as you see a proportion, you know what is the way to do this? What is the surefire way of solving this? Cross multiply, right? I mean, you realize that cross multiplying is the same thing I've been doing my whole life, right? So you go, is the variable happy over here? No. So what would I do? What would be the first thing I did to get rid of to help get that n happy? What would I do? Multiply both sides by 5, right? Well, guess what I'm doing? I'm multiplying both sides by 5 by cross multiplying. Does that make sense? Anyway, cross multiply. Okay, so over here I've got to go like this. It's going to be in parentheses here, in parentheses here. What is it? Rainbow? Rainbow. 5 times 3n? 15n. 5 times 3 plus 15 equals. Then I go over here. Rainbow, rainbow. 10 times 2n? 20n. 10 times negative 4? Minus 40. Is the variable happy now? Not at all. Not alone. Not. He's separated. He hates that. Is there anything I can reduce over here to make that simpler? Can I simplify anything here? No. Can I simplify anything here? No. What do I do then? What do I do? I need to get rid of the smallest of the two variables, right? Which is minus 15n minus 15n. 5n minus 40 equals 15 plus 40 plus 40. I have 5n, I'm out of room here. 5n equals 55, divide by 5, divide by 5, n equals 11. How many of you got n equals 11? Booyah, booyah, right? No big deal. You just combine lots of things that we've already learned here into one big problem, and you did it, right? That's a big deal. That's a booyah. On the next one, 2 centimeters. Here's my map. 2 centimeters is 25 feet. It says if on the map the rock to the tree is 12 inches, how far is it really? So here's the deal. If it goes 2 centimeters is 25 feet. Oh, I did inches. This whole question's done, right? You should have all been like, ugh. Unless you know the ratio of inches to centimeters. You guys, did you all figure out that I meant centimeters here?
No.
Oh, then that would be a mess. Then you would be able to see. Then you would say, I don't know. The tree is 12 centimeters. How far is it really? I meant centimeters. This is what you would have done. Equals 12 centimeters over how many feet? And so then we would do this. 2 question mark equals, what's 12 times 25? 300. Divide by 2, question mark equals 150. See, I messed up by putting inches here. You should have all been like, what?
I thought you were that's just exchange. No, we thought it changed.
That would make no sense. What is the ratio of centimeters to inches? Does anybody know? It's like 2 point. Right. It's got to be something, though, right? You had to, then you would have had to have done that. You would need to know that. And so everybody should have been like, what are you talking about? You know, like, what is that? You should have said that. But since you all didn't, you all got it wrong. I noticed my own mistake. You should have all.
I got 150 feet. Yeah.
But if I left it as inches, you should have been like, what? That doesn't make any sense.
I didn't see that.
See, well, then you should have. I did. When I read the reject who wrote the question, I said, hey, that's a mistake, you know, like I saw. Yes. Do you know the ratio?
No, but like.
Then how can you do that? No, it's not. You need to know the exact. In order to do that, you'd have to know the exact, like how many centimeters are there in an inch. Otherwise, you can't do that. Anyway, I'll let you guys get started. I think you guys are going to be fine. Okay, page 114, 9 through 40 even. Let me make sure that that's something that you can do. 9 through 40, no problem. No problem. You're on it.